what I want to do in this video is give you a bunch of properties of limits. And we're not going to prove it rigorously here. In order to have the rigorous proof of these properties, we need a rigorous definition of what a limit is. And we're not doing that in this tutorial. We'll do that in the tutorial on the epsilon delta definition of limits. But most of these should be fairly intuitive, and they're very helpful for simplifying limit problems in the future. So let's say we know that the limit of some function f of x as x approaches c is equal to capital L. And let's say that we also know that the limit of some other function, let's say g of x as x approaches c, is equal to capital M. Now, given that, what would be the limit of f of x plus g of x as x approaches c? Well, and you could look at this visually. If you look at the graphs of two arbitrary functions, you would essentially just add those two functions. It'll be pretty clear that this is going to be equal to, and once again, I'm not doing a rigorous proof. I'm just really giving you the properties here. This is going to be the limit of f of x as x approaches c plus the limit of g of x as x approaches c, which is equal to, well, this right over here is, let me do that in that same color. This right here is just equal to L. It's going to be equal to L plus M. This right over here is equal to M. Not too difficult. This is often called the sum rule or the sum property of limits. And we could come up with a very similar one with differences. The limit as x approaches c of f of x minus g of x is just going to be L minus M. It's just the limit of f of x as x approaches c minus the limit of g of x as x approaches c. So it's just going to be L minus M. That's often called the difference rule or the difference property of limits. And these, once again, are very, very, hopefully, reasonably intuitive. Now, what happens if you take the product of the functions? The limit of f of x times g of x as x approaches c. Well, lucky for us, this is going to be equal to the limit of f of x as x approaches c times the limit of g of x as x approaches c. Lucky for us, this is kind of a fairly intuitive property of limits. So in this case, this is just going to be equal to, this is L times M. L times, this is just going to be L times M. Same thing if we, instead of having a function here, we had a constant. So if we just had the limit, let me do that same color, the limit of k times f of x as x approaches c, where k is just some constant, this is going to be the same thing as k times the limit of f of x as x approaches c, and that is just equal to, this is just equal to L. This is equal to L, so this whole thing simplifies to k times L. And we can do the same thing with difference. This is often called the constant multiple property. We can do the same thing with differences. So if we have the limit as x approaches c of f of x divided by g of x, this is the exact same thing as the limit of f of x as x approaches c divided by the limit of g of x as x approaches c, which is going to be equal to, I think you get it now, this is going to be equal to L over M, over M. And finally, this is sometimes called the quotient property. Finally, we'll look at the exponent property. So if I have the limit of, let me write it this way, of f of x to some power, and actually let me even write it as a fractional power, to the r over s power, where both r and s are integers, then the limit of f of x to the r over s power as x approaches c is going to be the exact same thing as the limit of f of x as x approaches c raised to the r over s power. Once again, when r and s are both integers and s is not equal to 0, otherwise this exponent would not make much sense. And this is the same thing. This is the same thing as L. This is the same thing as L to the r over s power. So this is equal to L to the r over s power. So using these, we can actually find the limit of many, many, many things. And it's what's neat about it is the properties of limits kind of are the things that you would naturally want to do. And if you graph some of these functions, it actually turns out to be quite intuitive.